In section 3.4, we're going to look at transformations for our basic or parent functions, which we were introduced to earlier in chapter 3. First, let's talk about a vertical translation. A vertical translation is also known as a vertical shift or a vertical slide. In a vertical translation, the parent graph basically is moved vertically, either up or down. Up movement includes adding a positive number. Down movement involves subtracting a positive number. Notice in the graphs that we have here, the green graph is for the function y equals 3 times x squared. If we add 2, so that y is equal to 3x squared plus 2, then the graph moves up by 2 units, creating the blue graph. If, however, we subtract, say, 3 units, then the graph moves down by 3 units, creating the red graph. So in this case, adding 2 moves the graph up 2 units. Subtracting 3 moves the original basic graph down 3 units. The reason we call basic functions parent functions is that we can create transformations, and these transformations are called the child functions because they're derived from the parent. Let's practice with the vertical translations. Here we have f of x is equal to x squared plus 2. Well, the parent function would be the square function. So I'm going to say that the parent function is y equals x squared. I'm going to go ahead and graph the parent function. We know that this is a parabola, and let's see, when 3 is squared, we get 9. When we square -1, we get 1. When we square -2, we get 4. When we square -3, we get 9. So this right here would be the parent function. I'm just going to put this curve in with a dashed blue ink to show that this is where it starts. However, we're going to be adding 2, which is going to create a vertical translation 2 units up. So all of these blue guiding points, I'm just going to move them up by 2 units. So that is going to go up 2 units. This one is going to go up 2 units. This point is going to go up 2 units, and so on. So if all the points move up 2 units, then I'm going to have the graph of f of x. So the graph here in green would be the graph of f of x. The graph in blue is the original basic function, which in this case was the square function. In the second example, we have f of x is equal to the absolute value of x minus 4. Here, the parent function is our absolute value function, which has the equation y is equal to the absolute value of x. Again, let's just graph this as a dashed line for reference, and then we'll look at how to use a vertical translation to create the desired graph of f for f of x. So in this case, the parent function has 4 subtracted from it, which means that all of my points have to move down 4 units. So let's start with 0, 0. That would move down 4 units. This point would move down here, and so on, and so on, and so on. So now, if I connect the dots, I see that what I'm tracing here in green would be the graph of the desired function for f of x. When you're working on these problems, of course, in my math lab, you're not going to have the option to draw them by hand, which is why we like to include the graphing project so that you can practice graphing manually. But so that we don't get confused, I'm going to erase those original points. Ooh, I erased too much. I can always draw that back in so that you know that the desired graph is what happens after the movement. Now let's talk about horizontal translations or horizontal shifts, horizontal slides. It will involve adding and subtracting numbers to the original parent function, but in this case, the adding and subtracting happens with the input, with x itself. So note here, for instance, let me make this just a tad larger so we can see better. If we start out with y equals 3 times x squared, we have the green graph. Notice what happens when we subtract 2, but not from the rule itself, but from x, the input. So we are subtracting 2 from x, then squaring, and then multiplying by 3. So because we're doing the subtraction on x and not on the entire rule, this is going to create a horizontal translation versus a vertical translation. Let me remind you what a vertical translation, for instance, would look like. If we had y is equal to 3x squared and then subtract 2 from that, that would be a vertical translation. But that's not what we have here. We're subtracting 2 not from the original basic function, but from x itself. Now, x's behave in the opposite manner as what we would expect. When it comes to x's, subtraction is going to create movement to the right, and addition is going to create movement to the left. So in this case, the graph would move to the right 2 units. That is why the red curve here is 2 units to the right of the original basic function, which was in green. On the other hand, here we have 2 being added to x, and that is going to create movement to the left. We're going to move to the left 2 units. That is why you see the blue curve 2 units to the left of the original basic function in green. So again, horizontal translations are created by adding or subtracting values to the input x, not to the entire function. And it is the opposite movement as what would basically make sense. Adding a value to x creates movement to the left. Subtracting a value from x will create movement to the right. Let's practice with this idea. In the first example, we have f of x is equal to x plus 2 quantity squared. Well, the parent function is indeed the square function. So the parent function is y equals x squared. But notice that we're adding 2 to x, not to x squared. So adding 2 to x is going to create a horizontal translation. Basically, we're going to move the parent function 2 units left. So let's start by graphing the parent function, and I'm going to go ahead and do that here as a dash curve. Doesn't look quite as perfect as I would like it to, but we're going to erase it anyway. This is just for a guide. So moving everything 2 units to the left then would create points here, 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 and also here, and here, and lastly here and here. So by connecting the dots, now in green, I have the graph of f of x. Everything moved 2 units to the left. In the next example, we have f of x is equal to the absolute value of x minus 4. Here, the parent function is the absolute value function, with the equation y is equal to the absolute value of x. Now, we are subtracting 4, but we're subtracting 4 from x, not from the parent function itself. So that's going to create a horizontal translation, And in this case, it's going to be 4 units to the right. Remember that x's behave in the opposite manner as what we would expect. So 4 units to the right. The original parent function would have a graph that looks something like this. I'm going to do that as a dashed graph. And moving everything 4 units to the right then would basically give us a graph that looks like this now. So the graph in green is the desired graph for f of x, and later on you can go back and erase your guide, which was in the blue dashed graph.